Okay, so here's 6.2. We're going to look at multiplying and dividing our rational expressions. It's going to be very similar to 6.1, except we're just going to add multiplication and division. But basically, the idea is going to be the same. We're going to do a lot of factoring, and then we're just going to start canceling stuff out. And that's how it should work for the most part. First two examples are kind of just basic, just showing you how factors kind of cancel out and how we can do that. So looking at number 10 right here, we've got a 9 and a 3. So those are both divisible by 3. So we can go ahead and divide those both by 3 by reducing that there. And then you can see the 8 and the 2. Even though they're diagonal, that's okay. We can still reduce these. And those are both reducible by a factor of 2. So we divide each one by 2. So it'll give us a 4. Okay, so I'm going to go ahead and write what we have left. And so that's going to leave us with um, that'll leave us with 4w squared all over 3w to the fourth power. And then we do want to reduce those. And I know we haven't really gone in depth on our properties of exponents yet, but you should have prior knowledge for that though. And so what you can do basically is we're going to cancel these two out with two of these. And so our final answer would be 4 over 3w squared. And that's what we're looking at right there. And so this next one, 12, is really honestly, it's basically the same. It's just got a little bit more to it. It's got more variables and stuff. So if we look at this one, let's deal with the numbers first, and then we can deal with the variables second. So if we look right here, this 5 can reduce with this 20. The 6 and 12 can reduce right here. Okay, so let's go ahead and see what we have left. Okay, so you have a p squared, q to the fourth, and then another p squared. So whenever you multiply like bases, you add the exponent. So that should become p to the fourth, and then we've got a q to the fourth on top. Okay, and so that's part of the properties of exponents. Then p, there's only one p, so p right there. And you got q to the third, q to the second. That'll give us a q to the fifth when you add the exponents there. So then this p right here has an understood power of 1. Has an understood power of 1 right there. And so what we're going to do is this p is going to cancel out with one of these to where it leaves us with 3 on top, so p to the third. And then these 4 are going to cancel out with 4 of these that will leave us with a single q on top. I'm sorry, on bottom. So our final result would be p to the third all over q to the 1 power, which you really don't need to write the exponent. And so anyways, that was kind of a review of properties of exponents, to be honest. The rest of this is not going to really look like these first two problems. But like I said, we'll spend some time on those properties of exponents if you're a little rusty later on in a different section. Okay, so let's get down to the ones that we're going to see more of. So let's see, if we look at 14 right here. So like I said, the name of the game is going to be factoring. The only difference is we're multiplying these together. And so what you can really do is, I'll put this in parentheses, and I can just draw this right there and put a multiplication, put multiplication. And so basically, I just turned it into a single fraction. You can do that. That's fine. And so this is getting multiplied on top. This is getting multiplied on bottom. Now, you don't want to use the distributive property. You actually want to do the opposite. You want to just start factoring and trying to cancel stuff out. And so right away, you notice that we've got a 16z to the third and an 8z to the third. So the 16 and the 8, we can start reducing that right there. And so let's see. The 8 would reduce down to a 1, the 16 to a 2. And then you've got z to the third, z to the third. Well, those will both actually just completely cancel out, and you don't really have to worry about that. So let's go ahead and write what we have left behind. I'm going to move the 2 to the front, and then that's going to be times 3z plus 12. And then on bottom, this turned into a 1, so you're left with 1 times, and then you're left with this 9z plus 36 right here. And so what we'll do next is we'll go ahead and factor, and then things should start to cancel out, and it's just like the previous section. So on top, you should be able to pull out a 3. And so when you pull out a 3, that'll leave us with a z plus 4. On bottom, looks like we can pull out a 9. So we'll pull out a 9. That's going to leave us with a z plus 4. Oh, okay, that's interesting. So the whole idea is to break this down into multiplication factors. And so now we've done that, okay? So now, kind of like I said in previous lessons, it's either all or nothing. They either have to be an exact match or you can't really cancel them out whenever you kind of get something like a z plus 4 type thing. And so these are exact matches, so we can cancel them out. So we're left with 2 times 3 divided by 9. And there's a couple different ways you could go about this. You could go ahead and turn it into 6 over 9 and then reduce it. But later on, it's kind of easier to keep the numbers factored to start reducing, because then, isn't 9 the same thing as 3 times 3? It's 9 right here. And so then, once again, I have common factors that I can just cancel out. And this wasn't the only way you could have cleaned this up at the end, but that's kind of what came to mind for me. Okay, so let's go ahead and try this next one. So once again, what you can do is you can kind of just bridge this together, because that's what we're going to do anyways. There we go. This is getting multiplied there. And so once again, we're going to be factoring this stuff, but what we could do to start is, well, if we want, we can start by canceling these just single variables that are just kind of hanging out here. And so you've got x squared on top and x on bottom. So you can cancel this x out with one of these, and that'll just leave you with a single x. Okay. And then this y cancels out with this and turns that into a y squared. So basically, this just turns into an x up here, and then this leaves us with a y squared down there. Okay. Now time to look at the stuff we're going to have to factor here. All right, so in the interest of time, I'm just going to do guess and check on this, but you could, if you wanted, you could do your method where, you multiply the 2 and the 15 and you got to split that middle number. So that would be up to you if you wanted to do something like that. So I moved that x to the back and that y squared to the back. I could have put it in the front. It doesn't actually make a difference. But if you remember, I'm just going to do the reverse FOIL, and I'm just going to do it in my head because to save a little bit of time. But if you're unsure, you can look back at some old notes to figure out how to factor this. But basically, 2x and x is going to give me the 2x squared. Now I've got to get a plus 15, but somehow the inner and the outer has got to add up to negative 13. So it's probably going to be a 5 and 3. It's just a matter of where do they go. And so it looks like I'll probably have a minus 5 right here and a minus 3 right here. So if you look at that, that would multiply to give us the L part, the 15, and then the inner and the outer, if you multiply that together and add them, they add up to negative 13x. Okay, the second one's a little bit easier to factor. So let's see. Once again, you're basically doing a reverse FOIL. So what multiplies to give us negative 5, but add to negative 4? So that's going to be a minus 5 and a plus 1. Doesn't matter what order I list them. And then, so you should notice that you do have the x minus 5s are going to cancel out with each other. So that's good. So that cancels out. And so our final result, and it doesn't matter where you put the x and the y squared. Typically, we'll move them to the front. I guess that looks a little bit nicer. So you have x times 2x minus 3. And there's no reason, you don't need to distribute it. We actually want to keep it factored. And then on bottom, let's see, we'll put that y squared up front. And we're going to have an x plus 1. And that's what we're looking at on that one. And basically after doing this one, the rest of them are going to just be really similar to this. We are going to throw division in there on the next page in just a second. So let's go ahead and look at 16. And I almost advise you just to go ahead and pause this video and try it on your own. But anyways, I'll leave that up to you. Let me clean this up a little bit. So the name of the game is just factor, and then start canceling stuff out. So if you look at this first part right here, it looks like a nasty factoring problem, but honestly, if I pull out a 3 to begin with, it's going to make it to where the problem's not all that bad. So we'll pull out a 3, so that'll turn that into a y squared plus 6y plus 5. And then we've got a y minus 5 right there. Okay, and then on bottom, we can see, oh, there we go. We will see that on this one right here, we can pull out a 6. So we'll pull out a 6. It's going to leave us with a y plus 1. And then hopefully you recognize the difference of two squares right there. So we're going to get a y plus 5 and a y minus 5. And so we still need to factor this part right here. But before we do that, might as well just kind of start canceling some stuff out, and then we'll deal with that in just a second. So let's see, the y minus 5, and then the 3 and the 6, we can reduce that down. So we're left with this trinomial, and we'll factor that into y plus 5, y plus 1. And then on bottom, we're left with a y plus 1. Oops. Okay, sorry about that. Okay, so let's see, we're left with this y plus 5 down here, and then we don't want to forget about the 2 we had. And so basically, all this stuff here cancels out. So this cancels with this, and this cancels with this. But what you want to realize is, are these really turned into 1s? So you got to kind of be careful here. So on top, yeah, you end up with 1 times 1, which is 1. And then on bottom, you end up with 2 times 1 times 1, which is 2. So actually, this whole thing simplified into 1/2. It's kind of interesting. Okay, so what I'm going to do is stop this video, and I'll make another one for the next slide.